The topic here is decomposition. Sometimes we start with a function that's somewhat complicated and we want to decompose it, which means that we want to rewrite the function as a composition of two simpler functions. For example, let's decompose this function, k of x, which equals x minus 3 quantity squared plus 7. What we want to do is rewrite k of x as the composition f composed with g of x, and figure out what are the functions f of x and g of x that would work, so that would be true. There's more than one way that this problem could be answered. First, let's look at the function k of x, which is x minus 3 quantity squared plus 7, and think about what an inner function might be, so that we'll get the composition we want. The inner function would be the one we'll call g of x when you have the expression that k of x equals f of g of x. You see how g of x is the inner function there. Looking at the expression for k of x, somebody might think, well, the first thing that gets done with the x is that you have x minus 3. And so x minus 3 could be that inner function. That is, g of x would equal x minus 3. Then we have to determine what f of x would need to be. So what does the function f need to do with the x minus 3 so that we would end up with the k of x function, x minus 3 quantity squared plus 7? The function f would need to square that expression x minus 3 and then add a 7. So a skeleton formula for the function f would be that its input value is squared and then a 7 is added. That means that the formula for f written out in the typical way as f of x would be that f of x equals x squared plus 7. We can check to see if we've got a good answer here. The f of x we had was x squared plus 7. The g of x we'd proposed was x minus 3. F of g of x would be f of, and we'd replace g of x with its definition, x minus 3, and then put that as input into the formula for f, getting x minus 3 quantity squared plus 7. That is k of x, so we do have a correct answer here. However, there's another way to look at this problem. Let's look at k of x again in part B here, and think about what the outer function might be. You can think about the outer function or the inner function first. So in this approach, we're going to think of an outer function. The outer function would be the f of x function when k of x equals f of g of x. One possibility is to think of the final thing that's getting done in this function, the outer part, as being simply add a 7. That's the final thing that's done in the formula for k of x. The skeleton formula for that outer function would be that f is to take its input and then add 7 at the end. The inner function would be the expression that belongs in that parentheses there that we're going to then add a 7 to. For this problem, what we'd want in those parentheses is x minus 3 quantity squared. That's the thing that's supposed to have a 7 added to it in order to end up with the whole function k of x. That inner function would be the one we'd call g of x in this case. So f of x would be formed from the skeleton formula here. It would be f's input has a 7 added to it. G of x formula would be x minus 3 quantity squared. Let's check if those two work. F of g of x would be f, and then inside the parentheses we'd put the formula for g of x, which is x minus 3 quantity squared. Then apply the f function to that. The f function says to take its input and add 7, so we take that input and add 7. Look at that formula, and it does match the k of x that we started with. Notice, that answer is not the same as we got the first time we decomposed this problem. There were two entirely separate ways of decomposing k of x. They're both correct ways. There's actually a way to decompose the function k of x as the composition of 3 other functions, so that k of x would equal f of g of h of x. Let's find functions f, g, and h that would make that work. Look at the original function k of x equals x minus 3 quantity squared plus 7. Think about what's the most inner function. The first thing that's getting done to the x is x minus 3, so 3 is getting subtracted. That would be the inner function. The h of x would be x minus 3. Then what gets done to the x minus 3? Well, it's squared. So the next function, g of x, would be x squared. And finally, a 7 is added to the x minus 3 quantity squared. So the final function would be f of x equals x plus 7. We can check that. If f of x were x plus 7 and g of x is x squared and h of x is x minus 3, then the composition of the three functions in this order, f of g of h of x, would be f of g, and then in the parentheses next to the g would go the formula for h of x, which is x minus 3. Then that would be used as an input to the g function. That means we'd have inside here x minus 3 quantity squared. And finally, that would be used as input to the f function, which would give x minus 3 quantity squared plus 7, which is the function k of x. And so we've decomposed k of x as the composition of three separate functions.